Okay, so this is going to start a series of videos that you're going to do while I'm away. Okay, the first one is just introducing logarithms and what they are. By the time you get to this, you should have already listened to me mention it in class one day before I leave, and then watched a couple of videos that I'm going to leave you links to. If you haven't done that yet, you need to stop, go back to Plus Portal, and find those assignments and do those. So let's get started. Okay, this video will go straight through your note-taking guide. It won't be the PowerPoint, but it will be all of the examples on your note-taking guide. So you'll need to do those as we go along. So number one, a logarithm is an exponent. Logarithms are the inverse of an exponential function. So if you'll remember, we talked about exponents and how you find inverses in Chapter 6. And what we did is we reversed them and then solved. So the left side we would read x is equal to b raised to the y power. This side we read the log base b of x is equal to y. So what is the exponent that I would raise b to get the amount x? That's going to be what we're looking for. So let's do some. 6 squared is equal to 36. So we take the square root, so b is equal to 6. It doesn't really look. B is equal to 6. 2 is equal to y. So here's my base, here's my exponent. And 36 is equal to x. So I can write it as log base 6 of 36 is equal to 2. When I read it, I could say, what exponent do I raise 6 to get 36? Oh, that would be 2. Here we have 4 to the negative third. I can rewrite that as 1 over 64. In a log form, I'm going to write it as log base 4 of 1 over 64 is equal to negative 3. Another example, 17 to the 0 power is equal to 1. So log base 17, the power that I would raise 17 to get 1 is equal to 0. X to the t equals p. To rewrite that in log form, log base x of p is equal to t. What power do I raise x to get p? That would be t. 10 squared is equal to 100. So we would say that that is log base 10 of 100. It would equal 2. We could also write it as the log of 100 is equal to 2. Base 10 is what we consider the common log, and that's what's represented on your calculator with just the log button. Now let's go backwards. Given a log function, how could we write it as an exponent? The log base 2 of 8 is equal to 3, so now I know 2 to the third is equal to 8. The common log of 1,000 is equal to 3. Since it's a common log, I know that it's a base 10, so 10 to the third is equal to 1,000. The log base 8 of 1/4 is equal to negative 2/3. So we know that 8 to the negative 2/3 is equal to 1/4. We can check ourselves by saying what is the cube root of 8? That would be 2. And what is 2 to the negative 2? 1/4. Log base 4 of 16 is equal to 2. We know that 4 squared is 16. Now we're going to do some evaluating. Notice that you only have this part, the log base 3 of 81. What we're going to do in order to evaluate that is we're going to set it equal to x. Now we're going to go from from log form to exponential form. 3 to the x is equal to 81. If my bases are the same, it's much easier to solve. I can rewrite 3 to the x, and then I can write 81 as 3 to the 4th. Since my bases are the same, the exponents also have to be equal. So we find that x is equal to 4. Let's do another one. Now we have log base 8 of 2 is equal to x. So I want to know what 8 to the x power is equal to 2. So now I can rewrite 8 as 2 to the 3rd. I have 2 to the 3x is equal to 2 to the 1st. Since my bases are the same, then my exponents have to be equal, and I just solve for x. Log base 10 of 1,000 is equal to x, so 10 to the x is equal to 1,000. We know that 1,000 is a power of 10, so I can rewrite that, and again, x is equal to 3. Here are a couple more examples. The log base 9 of 27 is equal to x, so we're going to rewrite that as 9 to the x is 27. We'll rewrite 9 as a power of 3 and have 3 to the 2x is equal to 3 cubed. 2x equals 3, x equals 3 halves. Once you get it to this part, it just becomes simple algebraic work. Here, log base 6 of the square root of 36 is equal to x. The log base 6 of 6 is equal to x, so we rewrite it as an exponent, and we find that x is equal to 1. Finally, the log base 5 of 1/5 is equal to x. So 5 to the x is equal to 5 to the negative 1. Remember that 1 over 5 is the same as 5 to the negative 1. So x is equal to negative 1. Here's a problem that you have in your notes where it talks about the intensity of earthquakes. And it asks for what is the difference, how many times more is the earthquake in 1995 than in 2001. We know that the initial earthquake was 8.0 and the second one was 6.8. So the log is the ratio. They give you this, that the log is the ratio and is equal to the difference of the magnitude. So we know that the magnitude difference is 1.2. And then we're going to rewrite this. So when we rewrite it, we get 10 to the 1.2 is equal to whatever that ratio is. And we find out that the first earthquake was 15.85 times more than the second. So you'll find that as we do logarithms, there are lots of scientific applications. There are also a lot of finance applications that you'll see, and we'll be doing quite a few problems with those. For now, we're going to skip graphing. We'll go with that when I come back. But I want you to be sure and see how the log is the inverse of the exponent. Notice here how I swap x and y. And then I rewrite it so that I solve for y. Y is equal to 3 to the x. So these two functions, both logs and exponents, are inverse functions of each other. So here, when we're writing them, what do we first do? We first swap, and then we solve for y. So we know that 10 to the x, because this is a common log, 10 to the x is equal to 15y. So we divide by 15, and we're left with y is equal to 10 to the x over 15. And again, here we swap the x and the y, just like we did in Chapter 6, and then we rewrite in terms of y. So take some time to study these examples. Normally we would take about 15-20 minutes and go over it in class, and I did it in about 10. So I want you to just take some time, look at the examples, rework them before you go on and do your homework assignment. On your homework assignment, you should have both a Math Excel assignment, and then you'll have, once you finish that, then you'll have to do the daily check. Your substitute will have your password, and then you can go on to the next section once those two are done online. And I'll be checking this for you over the next few days. I'll be checking in on your work to see how you're doing from my end.